Hello everyone. So today in last class we have discussed all the preparation, right? So we'll be doing some questions of preparation. So let's focus on this question. Okay. So they are saying that Hoffman bromodiamide degradation reaction. Now what was Hoffman bromodiamide degradation reaction? It was something like this, right? The first point that you have to remember that only primary sorry the rule was RCONH2 will be there, and then it will react with Br2Cl2 or NaOH, and it will give you what? R, that CO will be removed, and then here you will get NH2. Yes or no? So now which one will give this reaction? So basically I have to find MIT. Yes or no? So this one here they have given AR. Now what is AR? Basically AR is basically phenyl, okay, or also called C6H5, right? Now this one is not possible because if it's AR, the first one AR NO2, so basically they are talking about NO2 and benzene ring, right? So here CO is missing, that amide group is missing, amide functional group, so A is not possible. B is also not possible because here given AR and H2, so basically this one is NH2 and then this one is AR, so here also amide is not there, so this one is not possible. Then third one, if I pay attention, so it's AR CONH2. So the moment I have seen this CONH2, that means this is my answer, because this is amide. The structure will be something like this, CONH2, right? I hope it's clear. So the option is this one. Now next question is, what is the best reagent for converting propanamine into propanamine? So what is propanamide? Amide, you know, amide has functional group CONH2. Yes or no? Propan means 3 carbon, so 1 2 3 and then CONH2, so 3 carbon done. Then you satisfy the hydrogen, so CH3 and then CH2. So this is propanamide. Now it's what? It's giving propanamine. So propanamine means 3 carbons, CH3 CH2 CH2, and amine means NH2 will be there. So I have only two preparation reaction that uses amine. The first one is Hoffman bromodiamide degradation reaction, right? So in Hoffman bromodiamide degradation reaction, if you notice carefully here, so it's given RCONH2. Yes or no? Right? So if it is RCONH2, then CO will be removed and NH2 will be there. So technically I can say that one of the carbon will be removed, right? Yes or no? Suppose CH3CONH2, and here you will get CH3NH2. So that is not possible, because here if you count, here also 3 carbons are there and here also 3 carbons are there. Then another reaction is, if RCONH2 is given, then the reaction was LiAlH4, ether and water, remember? So in that case what will happen? This O will change to CH2NH2. That means the total number of carbon in the reactant side and in the product side will be same. So my answer will be option 4. Are you getting it? I hope you got this, right? Now next one is question number 15. Now in question number 15, what they are saying? They are saying that this one is reacting. So basically this one I have explained in previous class also, in previous video. So if RCOOH is used and NH3 and heat is given, then the COOH, the COOH part, it will change to CONH2, that means amide, right? So I'll be using the same concept here. So here they have given CH3 COOH and then NH3 heat is mentioned. So this one, this COOH part will change, right? So it will be CH3CONH2. Then what is the meaning of NaOBr? This is very important, okay? Try to understand this. Whenever NaOH reacts with Br2, then it gives NaOBr. Actually, this one is Hofmann bromidamide degradation reaction. Similarly, if they give you NaOHCl2, then you will get NaOCl. If NaOH is given and then not NaOH, sorry, if KOH is given and Br2 is given, then it will become KOBr. And if they have given KOH plus Cl2, then you will get KOCl. Okay, so it's like NaOBr means what? NaOH plus Br2. So it's an Hofmann bromidamide degradation reaction. So what will happen? This CO you will remove and your answer will be CONH2. Okay, so your A is what? A is CH3 CONH2 and B will be CH3 NH2. Okay, let's move on to the next question. Next question, they are saying, question number 16, how to convert benzoic acid to aniline. This question is similar to the previous question but slightly different. Okay, like different is they have given name. So what is benzoic acid? I know that COOH and then benzoic acid, right? And they are saying that you change this benzoic acid to aniline, NH2, and this one. How I will do that? similar to the previous question. So what I will do, that COOH, it will react with NH3 heat, right? So it will change to CONH2 and then it will react with Hofmann bromidamide degradation reaction. So I will be using Br2 and KOH. So this CO will be removed and then you will get NH2 and then this will be your answer. So with that we got the answer. Alright. Now let's do question number 18. So actually question number 18, the first part is from haloalkane haloarine chapter. So in this case, what was the thing? If you remember, it is from substitution nucleophilic reaction. Okay, so if Rx is given and then KCN is reacting with KCN, so the nucleophile that you will get is CN minus, yes or no? So what it will do, it will replace this X and you will get here NC. Okay, so suppose if I am giving here CH3 CH2 Cl and is reacting with KCN, so this halogen part, it will be removed and in its place what you will get? You will get CN. Okay. Now if I use the logic here, so question number 18 is given CH3 Br and here is reacting with KCN. So obviously that Br will be removed and here Cn will be there. Now it's reacting with LiAlH4, right? So when it reacts with LiAlH4 and nitrile is there, so that Cn part, it will change to, that Cn will change to CH2 and NH2. In last video I have explained that. Okay, now last question from the preparation part. I hope it's last question. No, okay, few more questions are there. So the first question is how to convert nitrobenzene into aniline. So what is nitrobenzene? Nitro means NO2 and benzene is this one, and it's changing to aniline. So basically this is the first preparation reaction, okay, where you can use SN plus HCl also. So NO2 will be replaced and in its place you have to write NH2. So that's your first question. It's very simple. Then they are saying that how to convert ethanamide to methanamide. So what is ethanamide here? Ethanamide. Amide stands for, what is amide basically? Amide stands for CONH2, yes or no? So ethane means two carbons, one carbon from alkyl part, another carbon from amide, and is changing to methanamine. So CH, methane means one carbon and amine means NH2. So here the total carbon is what? 2 carbon, and here the total carbon is 1 carbon. Since 1 carbon is decreased, then definitely it is Hofmann bromidamide degradation reaction. So I'll be using Cl2 and KOH. Okay, so that's it. I hope you understood this. What I'm trying to say is, since since the total number of carbon is less in product side, one carbon is less in product side as compared to reactant, so it's always Hofmann bromidamide degradation reaction. Okay, and the third one is ethane nitrile to ethaneamine. So what is ethane nitrile? CH3 CN, because two carbon, one carbon from CN, another carbon from CH3 part is changing to ethaneamine, so it's CH3, two carbon will be there, and then NH2, right? So only one reagent is possible, it's LiAlH4. In its place you can use H2 nickel, right? Or in its place you can use C2H5OH and NaHg. Three reagents were possible. Okay. Now this question is very important. Theory based questions are generally important. Okay, now they are saying that a aromatic compound C7H6O2 C7H6O2. So whenever two oxygens are there, okay, like in this formula C7H6O2, if two oxygens are there, then two possibilities are there. One is carboxylic acid, another one that is RCOOH, another one is ester. Ester general formula is RCOOR. Okay, now, and another important thing is that if the number of carbon and number of hydrogens are nearly same, like 7 6 5 6 like that, then definitely there is benzene ring, which is again confirmed by this word aromatic. So let's see what will be our structure. So if I give you this one and then COOH, I have just drawn this structure randomly and I want to see that whether it's matching or not. Let's see whether it's possible or not. So I know that this structure is what I can also write this as C6H5COOH, right? Because this benzene ring structure, this part is C6H5. Yes. Now let's pay attention. So if I just combine them, 6 and 1 carbon, so it's 7 carbon, hydrogen 5 and 1 carbon is 6 carbon, and O2, so it's definitely matching, right? Now sir, now you will ask, sir, why ester is not possible? Let's read the question. On reaction with ammonia, aqueous ammonia and heating, that means it is reacting with NH3 and heat. So NH3 and heat is what? Is definitely a carboxylic acid that will give you amide. Yes or no? Right? So from here I got the hint. Then they are saying that it is reacting with Br2 and alcoholic potash. So what is Br2? And potash means what? Potassium. And alcohol means OH will be there. So definitely, because for alcohol the functional group is OH, right? So they are definitely talking about Br2 and KOH, right? So from there I got the idea that it's definitely the first reaction, like this one. So I know that we already did this question, okay, but just that they are asking it in language form. Previously we did one question like benzoic acid to aniline, is that same one, okay? So this one is reacting with NH3 and heat, so it's getting CONH2 benzene ring on the first carbon. Then it's reacting with what? Br2 and KOH, so you are getting NH2 and then this one, right? So this is your compound A, this is your compound B, and this is your compound C. All right, so that's your answer. I hope it's clear. Now these questions are from the next topic, so we'll discuss it now. Okay, so after we discuss the topic, then we will be doing these questions. Okay. So in today's class we'll be doing first physical properties. So we'll be doing physical properties of amine. Okay. So the first physical properties that we will be doing is solubility. So basically amines are soluble in water, okay. Amines are what? They are soluble in water, and they will ask reason for why they are soluble, because amine can form hydrogen bonding with water molecule. If you write this, you will get answer, you will get full marks for that, okay, if they ask question on this. Now they ask question on relations also. So few points. Aromatic amines are always insoluble. Are always insoluble in water, okay. Now if I am talking about aromatic amines, so what is aromatic amine? If benzene ring is connected to nitrogen, it can be this also, it can be this also, or it can be this also, where alkyls are connected, right? Clear? If benzene ring is directly connected to benzene ring, then that thing will be insoluble, always insoluble. Now for aliphatic amine, order of solubility, okay, order of solubility is always 1 degree amine, then 2 degree amine, and then you have this 3 degree amine, okay. Now what's the reason behind this? If I draw 1 degree amine, so it's RNH2, right, and then 2 degree amine is R2NH, and if it is 3 degree amine, then R3N, right. So how many hydrogen it has? This one has 2 hydrogen, right. So 2 hydrogen means 2 hydrogen bonding with water, okay. So this one has how many hydrogen bond? 1 hydrogen, not hydrogen bond, basically 1 hydrogen. So that means it will make only 1 hydrogen bond with water, and this one has 0 hydrogen. So since this one is 0 hydrogen, so it will never make no hydrogen bonding with water. I hope you understood this. So that's the reason, okay. So if they ask you why 1 degree amine is more soluble than 2 degree or 3 degree amine, you will say that in 1 degree amine you have 2 hydrogen with nitrogen, and those 2 hydrogens are involved in hydrogen bonding, so it gives 2 hydrogen bond, but in other case the number of hydrogen bonding is less, so that's why 1 degree amine is more soluble in water, okay. I hope you understood this. Right. Now next let's do some question. Suppose if I give you this one, so you already know how to identify 1 degree and 2 degree amine, right? So CH3 CH2 NH2 is there, so this is your first molecule. Second molecule is CH3 NH, and then CH2 CH3, and the third molecule is C6H5 NH2. Then if I ask you the decreasing order, of solubility, then what will be your answer? So this one I know that it's 1 degree, because along with nitrogen there are 2 hydrogens. This one, if you pay attention here, how many hydrogens are there? Only 1 hydrogen, right? So it is 2 degree. But this one, although it is 1 degree, but it is aromatic. Why I can say it's aromatic? Because C6H5 is there or not? Whenever C6H5 is there, so that means it's a benzene ring, and you know that aromatic amines are always insoluble in water. So what will be the order? Decreasing order means high to low, right? So it will be always A, because it's 1 degree, then molecule B, then molecule C. I hope you understood this. Right? Okay, then we'll discuss about boiling point. So this will be the last physical property. So basically, what is like how boiling point is actually related to the different degrees of, and basically under boiling point two types of question they can ask. The first question is that if all molecules are amine but having different degree, they have different degree. Okay, so here also so it will be always 1 degree amine, it will be always more than that of 2 degree amine, and then it will be always more than that of 3 degree amine. Okay, now why 1 degree amine? So here also the concept of boiling point is based on hydrogen bonding. If the number of hydrogen bonding is more, okay, so the molecules can hold each other properly. I'll explain it with diagram. So let's say R3N. So what is the reason? So you will say that it can make 2 hydrogen bond, it can make only 1 hydrogen bond, and there is no hydrogen bond. So that's why the order of boiling point is this one, that is 1 degree amine will have higher boiling point. So basically what is the whole logic behind this? So let's say I'm considering 1 degree amine, or let's say I'm considering 2 degree amine, so it will have this hydrogen, right? So this one hydrogen, and this is same, that same molecule. So let's assume that this is the molecule that we are using, right? Now there will be hydrogen between them, this red mark, can you see? So because of the presence of this hydrogen bond, here it's 2 degree amine, okay, the example that I'm taking. So 2 degree amine, it's only making 1 hydrogen bond, okay. Now this hydrogen bond, they hold the molecule strongly, okay, so that's why you have to apply more heat, so to break this bond and to change the liquid form of this amine into vapor. All right, so that's the whole logic behind it. So in case of 1 degree, what will happen? There will be 2 hydrogen bond, so you will be needing more heat, and if you apply more heat to change the amine into vapor state, means to boil it, that means what? Its boiling point will also be more, right? Understood? So just remember that with the increasing number of hydrogen bonding, the boiling point of amine also increases. Now second type of question is that if functional group is different. Second type of question is when functional group of compounds are different. Okay, so this same relation I have given in carboxylic acid chapter also. The first one is amide, then carboxylic acid, then you have alcohol, then you have ketone, then you have aldehyde, then you have amine, okay, continuation, okay, then you have halides, then you have ester, then you have ether, and then you have hydrocarbon. Hydrocarbon means it can be either alkane, alkene, or alkyne. Now what's the functional group of amide? The functional group of amide is CONH2, right? Carboxylic acid is COOH, alcohol is OH, ketone is CO, aldehyde is CHO, amine is NH2, and if it's halide then it will always have halogen with alkyl. Ester is COO, ether is O, right? These are the functional group. Remember, amine is having more boiling point than halide, okay? So the sequence is going like this. Okay. Now if I give you one question, suppose I am asking give me the order of boiling point. So let's say I'm giving CH3 COOH, then second molecule is CH3 CH2OH, then third molecule is CH3 CONH2, fourth molecule is CH3OCH3, okay? So and the last molecule is CH3 CH2 NH2. So what will be the order of boiling point? So now here first I have to identify that by looking into the structures, the formula, I know that they have different functional group, right? So first I have to identify that which is what functional group. So this one I know it's carboxylic acid, right? This one OH means alcohol. This CONH2 is what? Amide. This O, just O, is ether, and if it's NH2 then it is amine, right? Acha, you already know that amine can also be represented like in amine NH2 is not only amine. When I'm talking about amine here, it should be nitrogen, right? Because in previous lecture video I have already explained that, right? The hydrogen with nitrogen can be less also, like there can be no hydrogen, then also it's amine, right? So now use this one. I'm giving you 30 seconds. Use this one and try to arrange it. Okay, then let's start. So I know that amide will have the highest boiling point, right? Then carboxylic acid, and then you have this alcohol, and then you have this amine, and then you have this ether, okay? So this is the order of boiling point, okay? Clear? This is the order of boiling point. In exam time they might ask it in terms of increasing order, in terms of decreasing order. You can do it accordingly, you can arrange it accordingly, okay? So with this we are done with the physical properties part, okay? Now let's do some question based on that. So let's do this question number 23. So 23, they are saying that out of this CH3NH2, okay, and CH3OH, which one will have higher boiling point? Now whenever boiling point question comes from amine, so you have to ask yourself that whether it, like both the molecules that are given, they have same functional group or not. If they have different functional group, then to solve them the rule is different, and if they have same functional group, like all the molecules are amine, then to solve them it is different, right? So here I can clearly see that they have different functional group, right? So I'll be using the second rule that I have explained now. So this is alcohol or not, and that one is amine, right? So I know that alcohol has always higher boiling point than amine, so my answer is CH3OH will have higher boiling point than CH3NH2. You can write it in statement also, like CH3OH will have higher boiling point. Alright, understood? So that's the answer, okay? Alcohol will have higher boiling point than amine. Now let's do question number 24. So in question number 24, what they are saying, here also they are asking about boiling point. So just check the compound, and by looking at the compound I can clearly say that they don't have same functional group, yes or no? Right? Let's draw the structure. So butanol is CH3 CH2 CH2 CH2OH. You don't have to actually draw the structure. I'm drawing the structure just to show that why butane is called hydrocarbon, okay? But in exam time, just by looking into the structure, you can say that which one will have higher boiling point. So this is what? Butanol. So definitely I know that this is my alcohol, right? Then next one is butane amine. So CH3 CH2 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 and NH2. So this one I know that is an amine structure. and this one butane. So CH3, CH2, CH2 and CH2. So this one is butane, and is actually, since the whole compound is made up of carbon and hydrogen, so it is also called hydrocarbon, right? Now as per the second relation that I have explained, I know that butanol will have more boiling point than butanamine. And then lastly we have this hydrocarbon. Again I am saying any compound that is mainly made up of carbon and hydrogen, then it's called hydrocarbon, okay, as per that relation that I have given in under boiling point section. So this one is butane. So they are asking in decreasing order, so this is the decreasing order. Decreasing order is always big to small, right? So that's your answer. Got it? Okay, understood? So I'll be rubbing this and we'll be doing question number 25 on this page itself. So that's why I'm pausing for few seconds. Okay, now let's do question number 25. Okay, now let's do question number 25. Okay, so in question number 25 what they are saying, let's read the question properly and then we'll solve it. Okay, so propanamine and N-dimethylamine contain same number of carbon atom even though the propanamine has higher boiling point than this one. So okay, let's draw the structure. What is propanamine? Propanamine means 3 carbon, CH3, CH2 and CH2 and NH2, right? Then N-dimethyl methanamine. What is N-dimethyl? So methanamine means CH3 and N, but they have given that on N there is one amine and another amine also, like I'm using the concept of IUPAC. Now clearly I know that this one is also my amine structure and this one is also my amine structure, right? Yes, so I'll be using the first rule of boiling point. If the degree of if all the compounds are amine, right? So this one is what degree? It's 1 degree or not, because clearly I can see that with nitrogen there are 2 hydrogen, and here with nitrogen there are no hydrogens, so I can say it's a 3 degree amine. Yes. Now they are asking that what's the reason behind that, although the number of carbons are same. Very simple. 1 degree amine has what? Has more hydrogen bonding, and 3 degree amine has 3 degree amine makes no hydrogen bonding. So if you just write this reason, then it's more than enough. Okay, so that's the answer of this question number 25. Clear? Okay, then let's do the last question number 26. So question number 26, what they are saying, arrange the following molecule in the increasing order of boiling point. Okay, this question is slightly interesting because here they have given C2H5, right, NH2, and then C2H5OH, and then CH3 3 times N. So here this one is amine, right? This one is what? Alcohol, and this one is again amine. Yes or no? Right? Now if you pay attention, here 2 amines are there. So what I will do, I will first arrange them. They are asking increasing order, okay, so low to big. So what I will do, since 2 molecules are like 2 molecules, the first one and the third one is they are amine, so you identify the degree also. This one is clearly 1 degree and this one is 3 degree, right? So you know that 3 degree amine has the lowest. So now if I just generally arrange them, I know that CH3 and then C2H5 NH2 is clearly less than that of C2H5OH. I am not doing the arrangement of amine molecules first. I am just arranging it as alcohol versus amine. So I know that alcohol always have more boiling point than amine, right? Now here I can say that now I will be using the concept of amine. So 1 degree amine has more boiling point than 3 degree amine. So that's the answer for this. Okay. So what I did first I have arranged the amine and alcohol, right? I have ignored the degrees of amine for the first time. Now in the second step what I did, I have arranged the amine in terms of degree. That's the only thing. Okay, so that's the increasing order of boiling point. Okay, next one is question number 27. They are asking us the order of solubility. Okay, it's not boiling point. This question is related to solubility. All right, so solubility means what? It's always 1 degree, 2 degree and 3 degree, right? Yes or no? Now let's do that. So the first molecule is CH3, then 2 times is given and NH is given, right? So this is definitely what degree? This is 2 degree. Then they have given CH3 and H2, so this is 1 degree, right? And then when they have given C6H5 and H2, definitely I know that this is aromatic compound because C6H5 is aromatic. So aromatics are always insoluble in water. Here also they are asking it in increasing order. So increasing order means this C6H5 NH2 will have the least solubility. Then 1 degree or 2 degree, it will be 2 degree because 1 degree has 2 hydrogens, so it will be more soluble. So the second molecule is 2 degree, that is CH3 2 times NH, and lastly you have this CH3 and H2. So that's the order of solubility. Okay, got it? Now this increasing order of boiling point, this one will be homework for you. You try it by yourself. Here as you can see, the hint I can give is that all the 3 molecules are amines, so you just have to look the degree. Okay, so with this we are done with the questions. Okay, now let's do the chemical reaction of this chapter. Okay, so now we will be starting with chemical reaction of amine. The first one is alkylation. Now what will be alkylation? Let's say any amine is given and they have given an alkyl halide. Okay, so to differentiate it, I am just writing here 1. Now what you have to do, you have to remove 1 hydrogen from amine. So there are 2 hydrogens, so 1 hydrogen is removed, and on this nitrogen this halide will be, the halide from this one, like this one will be bonded here. Okay, by removing the hydrogen. Okay, so let's say every time, okay, it's not it's not like that every time they will be giving RNH2. They might give, this is 1 degree amine, right, RNH2, so they might give 2 degree and 3 degree also. All you have to do, you have to remove the hydrogen and in its place you have to add the alkyl part with respect to the bonding side. Okay, so let's do some questions. Suppose I am giving CH3 NH2 and then here is reacting with CH3 CH CH3 and then Br. Okay, so if it reacts, so this is the bonding side of the halide, right, and this is RNH2 part. So 1 hydrogen if you remove, so it will be CH3 and NH, right, 1 hydrogen is removed. Then this structure you reverse it. So if you reverse the structure, so it will be CH, then CH3 and then you have this CH3. Yes or no? This will be the bonding side. Yes or no? So it will be CH, then CH3 and CH3. Yes or no? Now let's do another question. Suppose I am giving you CH3 CH2 NH and then CH3, and is reacting with CH3 CH2 Br. In place of Br they can use other halides also, right? So this is the bonding side and this is the nitrogen. So remove 1 hydrogen from here. So it will be CH3 CH2 N and CH3, and then this one will be CH2 and CH3. Okay, right? Understood? Easy. Now the last one is, let's say I'm giving you this one, CH3 CH2 3 times nitrogen, so it's a 3-degree amine. Okay, and let's say it's reacting with this CH3Cl. Now here this 3-degree amine has no hydrogen with nitrogen, yes or no? So here, since hydrogen is absent, no hydrogen is there with nitrogen, so it will not give any reaction. So here you will not get any reaction, any product. Okay, clear? Got it? Because the general process is what? One hydrogen is removed and in its place, oh sorry, my mistake, this is not the one. It will produce quaternary ammonium salt. Okay, whenever it's 3-degree amine and no hydrogen is present. Actually this alkylation is some, except the first step, it is similar to ammonolysis process of preparation. Okay, so what will happen? It will make this CH3 CH2 3 times, right? The nitrogen and then this CH3, this positive charge will be there, and outside you will get one halide, that's Cl. This is quaternary ammonium salt, if you remember. Quaternary ammonium salt. Right, let's do one more question related to 3-degree amine, so that this concept of quaternary ammonium salt will be clear to you. So this one again, I am saying this part I did in ammonolysis part of preparation. So let's say I am giving you CH3 3 times nitrogen and it's reacting with CH3 CH CH3 and Cl. Okay, so what will happen here? So if you draw its expanded structure, I know that my structure will be something like the CH3N, and then this is the bonding site, and I will reverse the structure. Okay, so if you reverse the structure will become something like this, CH CH3 and CH3, right? And this will be the bonding site. I am reversing it so that this carbon, this circle carbon, can make bond properly with the nitrogen. So here you give one positive charge and then you write here Cl minus. Now if you want to draw this in expanded form, like this same structure, so it will be something like this, N CH3 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 CH CH3 and CH3. So this is your positive sign, then outside you will get Cl minus. So either you write this first structure or this you write this second structure, both are same. Okay, so this is also quaternary ammonium salt. Whenever 3-degree and it goes for alkylation, then it always produces quaternary ammonium salt. Okay, now this alkylation is also called, it has another name. Okay, so this alkylation is also called Hofmann exhaustive alkylation reaction. So they can also say this. Okay, Hofmann exhaustive alkylation reaction. All right. All right. Now next one. Next reaction is acylation. Now in acylation, what will happen? What will be the reagent here? Reagent can be acid chloride. Acid chloride you already know. What is acid chloride? It's RCOCl, which can also be written as RC double bond OCl, right? The second one is acid anhydride. So it will be RCO twice O, which you can also write it as RC double bond O C double bond OR, right? This one you already know. And the third one is ester. So ester is RCOO R, okay. So which you can also write it as R C double bond O R. Now here the most important thing is that for ester, like the confusion is only is only for ester, okay, but for acid chloride and acid anhydride it will be very simple. So I will explain the acid chloride and acid anhydride part properly, okay. So here what will happen, RNH will be there, and let's say any one of the reagent is given, okay, and when it will react, one of the hydrogen will be removed and then C double bond one more alkyl, okay, it will be bonded, okay. So how to get this one, so we'll discuss about this, okay. So this circle part how to get, I will explain now. So let's talk about, like, let's take the example. First I will explain acid chloride and then acid anhydride, okay. Acid chloride, so let's say I am giving you CH3COCl, okay. So here what is the alkyl here, CH3 or not? So the circle part will be, you just have to give the C double bond every time and then this CH3, this alkyl part. Let's do another example. Suppose I am giving CH3 CH2 COCl. So what's the binding site here, CH2, right? So this C double bond you give and then you arrange the structure, reverse the structure, so it will be CH2 and CH3. Let's do another question. Suppose I am giving you CH3 CH and CH3 and here I am giving COCl. So what will be the answer here? This C double bond O is fixed, okay. Now this CH is there or not? So this CH is the bonding site and here you will get CH, my mistake. So this one will be CH, then CH3 and CH3, okay. Let's take another structure. Suppose I am giving CH3 CH2 CH2 C double bond OCl. So what will be the answer that you will get here? This CH is the bonding side, right? That C double bond will be there and then CH2 and then CH3, okay, right? That's how we get the circle part. Now let's talk about acid anhydride. So if it's acid anhydride, here also same stuff, okay. You just have to take the R part. Suppose I am giving CH3 CH2O, twice O. So this is the R part or not, this whole thing, and this is my bonding side, right? So what I will do, I will just write C double bond O and then CH2 and CH3. If I give this one CH3 CH CH3 C double bond O C double bond O CH CH3 and CH. Here I have drawn the expanded structure. It does not matter, just take any one R. So this is the R and this one is my bonding site, right? So this C double bond O will be there and then this CH and CH3 and CH3, okay. I hope it's clear. Now the ester part is a bit different, okay. So if it's ester RCOOR, or I can also expand it like this, RC double bond OR. So this R is what is bonded to what? It's bonded to carbon or not? And this R is, it's bonded to oxygen. So you have to ignore the R part, that is alkyl part, that is bonded with oxygen, and you have to take the R part that is bonded to carbon. Let's do some example. Suppose I am giving CH3 CH2 COO CH3. So this part you will ignore because it is bonded to oxygen. So which part you will take then? You will be taking this part and this will be your bonding side, okay. So your answer will be C double bond O and then CH2 and CH3. Let's do some other example. Suppose I am giving CH3 CH CH3, C double bond O, CH3. So this part you will ignore, right? This whole part you will take, and this carbon will be the bonding side. So here it will be C double bond O, CH, CH3 and CH3. Let's do another example. This will be the last example. Suppose I am giving CH3, CH2, oxygen, C double bond O, CH3. So here which one you will ignore? This part is bonded to carbon. I will ignore this. I will be taking this one, and since there is only one carbon, that carbon will be behaving as bonding site. Now if I apply this whole concept that I have explained, let's try to do the actual question. Okay, now suppose I am giving this question. Let's say it's reacting CH3, CH2, NH2, right? Yes or no? And it's reacting with CH3, CH, CH3, CO, Cl. So what part you will get from here? So I know that this is the acid chloride part, right? So you will get from here RCO, CH, CH3 and CH3 or not? This is the part that you will get. Now from here, from this part, you remove one hydrogen. So your answer will be CH3, CH2, NH, and then C double bond O, CH, CH3 and CH3. That will be the answer. Okay, let's do another question. Suppose I am giving you CH3, CH, CH3 and NH2. Let's say it's reacting with CH3, COO, CH2 and CH3. So this is ester or not? So in ester, the part that is bonded to oxygen we ignore. So what will be the CO part? So C double bond O, that will be CH3 or not? Means I have to take this one. So what will be the answer here then? You remove one hydrogen from the nitrogen, it will be CH3, CH. So if you remove one hydrogen from this NH2, so there will be only one hydrogen and then C double bond O and CH3, right? That will be your answer. Let's do another question. Suppose I am giving you CH3, CH2, 2 times of NH, okay, and it's reacting with CH3, CH2, CO, twice O. So this is an acid anhydride part. So if it is acid anhydride, so what you will get here? So it's C double bond O. This part will be the bonding side. So it's CH2 and then CH3, right? So your answer will be CH3, CH2, twice, one hydrogen is removed, and in its place you write this one. Okay, I hope you understood this. So with this we complete our today's lecture. In our next lecture I'll be completing the remaining chemical properties. Okay, so thank you class and study well.